Well, how did you set up the problem?
I had the area equals x times 420 minus 2x.
Okay. That's right. Which is negative 2x squared plus 420x.
I kind of like math because I'm just
Right? Okay, now what am I interested in?
Finding out what x is.
That will make what happen?
To find the dimensions.
That will make what? What's the whole point of the problem? What do I want to do? I want to maximize the area. So what shape is this? If you were just to graph this equation right here, Matt, what would it be? Opening. I want its maximum. What am I looking for? The vertex. I'm looking for the vertex. So I need to find the vertex. And you can do that a couple different ways, but the easiest way is just negative b over 2a, which would be negative 420 over negative 4, which is 105. So this dimension is 105, and this dimension would be 210. So your answer is 105 by 210. That's the size of the area you want to enclose. Okay, who else? Is that it for the quiz? Are we all good on the quiz? Julie.
number 2 to find the Y-intercept.
How do we find the Y-intercept?
Set x to 0.
Let x be 0. Lily, I need you to stop and think about that. We shouldn't have to memorize that. If you are on the y-axis, tell me about every single one of these points. Any point on the y-axis. What do you know about its coordinates? Every single one of those. What do you know? X will be 0. You're looking for some point where x is 0. So you just plug in 0 and do the arithmetic. Okay? All right. All right, let's put those away. There's a couple of things I want to talk about today. One of them we've already talked about. So we're not going to talk about it anymore. But if we have a problem, let's say we have this polynomial. And clearly it does not factor by grouping. But my job is to find the roots, find the factors. Then I'm going to start just guessing numbers, right? Now you already have one tool to help you guess numbers. I mean, let's face it. If I just say to you start guessing, that's overwhelming. But you have a way of narrowing down your guesses. What's that called? The possible rational roots, right? And what would the possible rational roots for this problem be? Factors of 6 over factors of 1. So already you have narrowed down what was an infinite amount of possibilities. You've narrowed that down to basically 8 numbers. Now I want to give you a couple of other tools to keep in your toolkit. Not saying you have to use them on every problem, but just have them if you need them. Let's suppose that you guessed the number 6. It's in your list. You guessed it. If we were to divide 6 out, and notice I'm missing a squared, so I put a 0 in there. If I were to divide that 6 out, I don't know, those numbers got a little big on me. Does that look okay? I want you to notice that this, clearly 6 is not a factor, right? But what happened was actually valuable to me. Now, in this case, maybe not so valuable, but when this happens, when you get all positive numbers in your division, as you get your answer to your division, that means you have found an upper bound. What that means is there will be no answers bigger than 6. Well, there are no answers bigger than 6 anyway, so this wasn't a very good example. But just remember that when you divide in, if you pick a number that gives you all positives, don't pick any numbers higher than that. Whatever's in the list, don't pick them because that number is an upper bound. As opposed to, what happens if we were to try -3? Now, -3 is not a factor either, right? Because the remainder is -12. But look at these. What's happening to this set of answers that I got down here, this bottom row of numbers? What are they doing? They're alternating. When that happens, you have found a lower bound. So as you are guessing and dividing, if you get a string of all positive numbers, then do not pick any numbers higher than the one you guessed. Because if you have all positive numbers, that means you have found an upper bound. That means there are no answers higher than that. Likewise, as you're guessing and dividing, if you get alternating numbers, you have found a lower bound. So in this case, that would actually be helpful to me, because that tells me if -3 is a lower bound, then that tells me don't even bother trying -6. Because no number lower than this will work. Okay? Now, if neither one of those two things happen, then you don't have anything special going on. But if these things happen, you can narrow down your options sometimes. All right? Number 45 on page 224, let's look at that, because that has to do with this. Number 45. Okay, they have given you a picture. And they've told you that they're operating in this window. And you might recall there was a time we talked about hidden behavior. Degree of this polynomial? 4. Potentially then, how many times could it cross the x-axis? 4 times, right? How many times can we see in the window that they gave us? 2. So what they are asking you to do in this case is prove that if you have this picture, you can be confident that these are the only 2 real roots. that the other two roots must be imaginary. In other words, prove that the picture does not double back down and cross or touch or do something somewhere else. Prove that it doesn't do something like this. Okay? Now, in the window they gave you, you had no idea. I mean, stuff could be happening out here that you don't, or out there that you can't see. How might we prove that every real root is drawn in that picture? Think about this. How could you prove it? Bailey?
The highest number or the highest factor and the lowest factor.
Well, according to the picture, I have a root between 2 and 3. So if that is the only positive root, if there's nothing else out here, what should happen if I divide 3 into this? They should come out all positive, right? If they don't, what does that mean? There's another root out here somewhere potentially, right? So we need to do that division. We're going to divide by 3. Now, could I have picked 4?
Yeah.
Or 5? I just picked 3 because it was the smallest one I could get away with. And remember, we need all positive. What's your conclusion? There are no roots bigger than 3, right? So I don't have to worry about finding any roots out here. That's the biggest one right there. Now what am I going to do? Same thing with -2. And what should happen this time? They should alternate. How about it? So what did you just prove? There is no root lower than -2. So in other words, all of your roots are confined in that picture. Got it? Okay. All right, let's look at this problem. One more tool I want to give you to help you find the roots. Your job is to find the roots of this polynomial. Now, right now, you could do a couple of things. Could you list your possible rational roots?
Yes.
Yes. And there really aren't that many because factors of 10, 1, 2, 5, and 10, plus or minus over 1. Okay? And then you're just going to start guessing, right? Dividing, plugging in, whatever, however you do it, you're going to start guessing. If you get a row that's all positive in your division, then you know you found an upper bound. If you get a row that's alternating, you know you found a negative a lower bound. One more hint. There's something called Descartes' rule of signs. And Descartes' rule is kind of like the PRR rule. Sometimes it can be really helpful. For example, if you're doing a problem and the number at the end is a 7 and the number at the front is a 1, is the PRR rule helpful? Extremely. Because what does this tell you? You're going to try 1s and 7s and that's it. That's really helpful. But what if it's a number like 48? Then it's not quite so helpful because why? There's still a ton, right? There's still a ton. So sometimes the PRR rule is really helpful and sometimes it's not. Descartes is the same way. Sometimes it's extremely helpful, other times it's not very. This is an example of where it's very helpful. Let me show you how it works. Descartes' rule of signs breaks down the options by telling you how many positive real, negative real, and imaginary roots you're going to have. Now this can be really helpful because if Descartes has told you there's only one positive real root, and you guess 6 and it works, then you know you're done with positives. No more positives because there's only one. How do you figure out how many of these there are? Well, you go back to the original problem and you go through and simply count the number of times your sign changes. What I mean is, this is positive, this is positive, this is negative. So I went from positive to negative. So how many times did it change? Once. That means there is exactly one positive real root. Remember, in your options for this problem, we had 10, 5, 2, and 1. As soon as we find one positive root, we're done looking for positives, because there is only one. Now to do negatives, do exactly the same thing, only let x be a negative number. Okay, so think about this term. If x is a negative number, this term would be negative, wouldn't it? Mm-hmm. What about this term? Negative. And that, of course, is negative period. Negative 10 is just negative 10. Now, how many times does that sign change? Never. That tells me it would be a waste of time to guess any negative numbers. There aren't any negative numbers. Well, how many roots does this problem have altogether? If one of them is positive and none of them are negative, how many must be imaginary?
2.
Descartes is extremely helpful in this particular problem because you're going to start guessing. You have no choice. This doesn't factor by grouping. What numbers are you going to guess out of your pile? The positive ones. And as soon as you get one, you're done guessing because there's no more numbers that are going to work. Everything else is going to be imaginary. All right? So anybody see one that might work?
2.
You tried 2?
No, it's just a guess.
Yeah, I think 2 works. Oops, I got a 0 in there, don't I? So my one positive root is 2. What do I do with what's left? I'd love to factor it, but it's not going to factor. So what am I going to have to do? Negative b plus or minus the square root of b squared minus 4ac all over 2a. What's that discriminant? Negative 16. How about 4i? And as luck would have it, that's actually going to reduce, isn't it? Negative 1 plus or minus 2i. Remember when we cancel, we got to cancel on everything. So there's your 1 positive and your 2 imaginaries.
When you're doing the division for this problem, so the 0 comes from equals 0.
Mm-hmm.
So even if they equaled like 50, you put 50 in there. You divide. You put. So you also have to add what it equals when you synthetically divide.
I'm not understanding the question. Say it again.
So you have a 0 because you got that's what it equals to.
Okay.
So
Remember, the only case I care about is the one that ends in 0. So if this does not have a remainder of 0, I am moving on to the next number. So if I put a 5 here, I would not have gotten a 0, and I would have moved on. I don't care about that. The only ones I can use are the ones that end up in 0 because they are factors. The remainder is 0. That number is the remainder. If that's not 0, I throw it out and move on, okay? So we don't have to worry about it if it's not a 0. All right, let's do another one. So we can practice Descartes again one more time. This was a case where it was very useful. Let me show you a case where it's not so useful. I'll just make one up here. Okay, so we're not actually going to solve this because I made it up and who knows what would happen. But we're going to do Descartes' rule of signs. So you've got this big problem which has how many answers? 5. And we'd like to know if any of them are real and if any of them are imaginary. I'd like to narrow down my guessing. So look at the problem, go from term to term, and count the number of times you go from positive to negative. Okay, so this one, there's a change, right? There's 1. No change. Whoop, there's a change, right? And no change. So how many times did the sign change as I went from term to term?
2.
Twice. Now here is the tricky part, the hideous part about Descartes. This doesn't say there are 2 positive real roots. It actually says there are 2 or none. Imaginary roots always come in pairs. Think about when you get imaginary roots, like from the quadratic formula. What do you always have? You always have the plus or minus. So you would never get, x equals 3 plus 2i, unless you also got x equals 3 minus 2i. They always come in pairs. And because of that, every time you count your sign changes, you have to decrease by 2's. So I got 2 sign changes, but that means there could be 2, or actually there could be none. If I had gotten 3 sign changes, I could have 3 or I could have 1. If I had gotten 8 sign changes, which would never happen in this problem, but if I had a problem where I had 8 sign changes, it would be 8 or 6 or 4 or 2 or none. You have to keep counting down by 2's to accommodate potentially for all of these imaginaries that are going to come out of here probably. Okay, so to get the number of sign changes, or to get the number of positive real roots, you count your sign changes and then decrease by 2. Now the example I had up here a minute ago where we had this, how come I didn't count down by 2's? Because there was only 1. That's the best case scenario, because then you know for sure there's 1. But if there's more than 1, you have to count down by 2's. This is not very helpful to me. But it is what it is. All right, now negative reals. All right, remember we're going to put in a negative number. So here we go. If I put in a negative number, this would be negative. What would this be? Positive.
Negative.
That would be negative, because if you put in a negative, you're going to square it out. This would be, and that of course stays positive. So just think about putting in a negative number like negative 1. This term would be negative, this one positive, negative, negative, positive. Now how many times do we change? 1, 2, 3. Okay, this is hideous because there could be 3 or there could be 1. Now I guess this is somewhat helpful because it says there's a negative number out there, so maybe I would start guessing negatives, hoping to find it. How many imaginaries? Well, how many did you say there were altogether? Consider every possibility. So if we had 2 and 3, there would be none. But what if we had 2 and 1? How many are there altogether? If we had 2 and 1, that would leave 2. What if we had none and 1? What can you tell me about these numbers? When you figure them out, what kind of numbers do these have to be? They have to be even. Why do they have to be even? Because imaginary roots come in pairs. You can't have 1, you can't have 3. You have to have either 2 or 4. This is an example where it isn't very helpful. I don't do Descartes on every problem I do. I do it on the ones where it's going to help me. Okay, one more problem to look at, and then I'll be done, and we'll get our test back. Okay, the last one I'm going to do is actually one of your homework problems.
Basically, I feel like you're getting every.
Take a look, page 225, number 57. Number 57, we're going to use our calculator on this problem. This is an easy one, especially for you guys that are in econ. We have a supply function. And we have a demand function. Okay, P is the price. Determine the price for which supply equals demand. Let's just do that first. What are we going to do? Set them equal to each other. It says supply equals demand. Now we're going to do this on our calculators, but I don't know, so what do you want to do? How do you want to do this on a calculator? You've got a couple different options. What's your thought? Let's talk about both options. Bailey? If you get it equal to 0, which would be a great way to, wait a minute, what's that going to be, 74? Which would be a great way to do it. And you graph that on your calculator, and I have no idea, I'm making this picture up, I have no idea what it looks like. What would I be looking for? If I had my equation set equal to 0, what on this graph would I be looking for?
The zeros.
The zeros, where it crosses the x-axis, right? Of course, this one wouldn't make any sense because it is negative, and P, price, is not going to be negative. Okay, so that's one option. In a minute, you're going to do this. Anybody think of another option, or does everybody like that option? Grace?
Could you graph both of those and then find the intersection?
Absolutely. So you could stick this in as y1, stick this in as y2, and then instead of using your 0 button, use your intersect button, right? There you go. All right, so one way or the other, everybody do this. Does not matter to me which way you do it. And then we have to answer the second question. $36.27 as my price. Anybody confirm?
Can you not set them equal to each other and find P? And then plug P back in?
Or what do you mean, set them equal to each other? That's what I did, and I just
Yeah.
found P.
Yeah, because you do that algebraically instead of graphing it.
Solve this algebraically.
Yeah.
You can absolutely solve this algebraically, but that's a cube. This doesn't factor, so you're gonna be guessing PRRs,
Oh, okay.
none of which will work, so then you're gonna have to look for sign changes and guess numbers in between, and
Okay.
it would be a very long problem, but, yep,
Okay.
it's why I'm so tough. That's what I had to do when I was your age in this class, because we didn't have calculators. But it takes a long time.
Okay.
Now, the second part of the question says, determine the price, did it. How many hair dryers would correspond to this equilibrium price? Now, how will you figure that out? This was the equation for the supply of hair dryers, and this was the equation for the demand of hair dryers. What could you do? Oh, you guys. Pink, what could you do?
Plug P in.
Yeah, because if you plug P in, and does it matter which equation you plug it into? No, because you set them equal, kids. They're the same. If you plug 3627 into here, what's that going to tell you? How many hair dryers do I have in the factory ready to sell? If you plug P into here, what's it going to tell you? How many hair dryers are people willing to buy? You set your problem up so those are the same, so it doesn't matter. Just plug your P in here, and that will give you the answer to the question. That will tell you how many hair dryers there are. You will want to round that answer off to the nearest whole unit, because you can't sell half a hair dryer, right? Okay. All right, so let's take a look at our test then. Get that out of the way.
Where do we get that?
I will be picking these back up. Jenna, will you pick that off button there? I will come around with stickers